determine the columns in a table, decide what information you need to track about the subject recorded in the table. For example, for the customers table, name, address, city, state, zip code, send email, salutation and email address comprise a good starting list of columns. Each record in the table contains the same set of columns. For example, each record contains data about one customer and the address field contains the address of that customer. Once you have determined the initial set of columns for each table, you can further refine the columns. For example, it makes sense to store the customer name as two separate columns, first name and the last name, so that you can sort, search and index on just those columns. Similarly, the address actually consists of 5 components: address, city, state, postal code and country. And it also makes sense to store them in separate columns. If you want to perform a search, filter or sort operation by state, for example, you need the state information stored in a separate column. In here, the most important thing is don't include calculated data. Instead, perform the calculations using the data in database when you want to see the result. Next thing is store the information in its smallest logical parts. You may be tempted to have a single field for full names or for product names along with the product descriptions. If you combine more than one kind of information in a field, it is difficult to retrieve individual facts later. Try to break down information into logical parts. For example, create separate fields for the first and the last name and for product name, category and the description. Once you have refined the data columns in each table, you are ready to choose each table's primary key. Each table should include a column or set of columns that uniquely identify each row stored in the table. This is often a unique identification number such as an employee ID number or a serial number. In database terminology, this information is called the primary key of the table. If you already have a unique identifier for a table, such as a product number that uniquely identifies each product in your catalog, you can use that identifier as the table's primary key. But only if the values in this column will always be different for each record. You cannot have duplicate values in a primary key. For example, don't use people's names as a primary key because names are not unique. You could easily have two people with the same name in the same table. And the other thing about primary keys are, a primary key must always have a value. If a column's value can become unassigned or unknown or missing at some point, it can't be used as a component in a primary key. You should always choose a primary key whose value will not change. In a database that uses more than one table, a table's primary key can be used as a reference in other tables. If the primary key changes, the change must also be applied everywhere the key is referenced. Using a primary key that will not change reduces the chance that the primary key might become out of sync with other tables that reference it. Often, an arbitrary unique number is used as the primary key. For example, you might assign each order a unique order number. The order number's only purpose is to identify an order. Once assigned, it never changes. If you don't have in mind a column or set of columns that might make a good primary key, consider using a column that has an incremental number data type that automatically generates when you are adding records to the table. We call them auto number fields. Such an identifier is factless. It contains no factual information describing the row that it represents. Factless identifiers are ideal for use as a primary key because they do not change. A primary key that contains facts about a row, a telephone number or a customer name, for example, is more likely to change because the factual information itself might change. A column set to the auto number data type often makes a good primary key. So in here, no two product IDs are the same. In some cases, you may want to use two or more fields that together provide the primary key of a table. For example, an order details table that stores the line items for orders would use two columns in its primary key, order ID and product ID. When a primary key employs more than one column, it is also called a composite key. Now just tell me, as in this illustration, what are the auto number columns of these four tables that serves as a primary key? Yes, product ID for the product table, order ID for the order table, customer ID for the customer table, and the supplier ID for the supplier table. Now that you have divided your information into tables, you need a way to bring the information together again in a meaningful way. In a relational database, you divide your information into separate subject-based tables. You then use table relationships to bring the information together as needed. Consider this example. The suppliers and the products table in this database. The supplier can supply any number of products. It follows that for any supplier represented in the supplier table, there can be many products represented in the products table. The relationship between the suppliers table and the products table is therefore one-to-many relationship. To represent a one-to-many relationship in your database design, take the primary key on the one side of the relationship and add it as an additional column or columns to the table on the many side of the relationship. In this case, for example, you add the supplier ID column from the supplier table to the products table. We call this supplier ID in the product table as foreign key. Now consider the relationship between the products table and the orders table. A single order can include more than one product. On the other hand, a single product can appear on many orders. Therefore, for each record in the orders table, there can be many records in the products table. And for each record in the products table, there can be many records in the orders table. This type of relationship is called many-to-many relationship because for any product, there can be many orders. And for any order, there can be many products. Note that to detect many-to-many relationships between your tables, it is important that you consider both sides of the relationship. The two tables, order and the product, have a many-to-many relationship. This presents a problem. To understand the problem, imagine what would happen if you try to create the relationship between the two tables by adding the product ID field to the orders table. To have more than one product per order, you need more than one record in the orders table per order. You will be repeating the order information for each row that relates to a single order, resulting in an inefficient design that could lead to inaccurate data. You can run into the same problem if you put the order ID field in the products table. You would have more than one record in the product table for each product. How do you solve this problem? The answer is to create a third table, often called as junction table, that breaks down the many-to-many relationship into two one-to-many relationships. You insert the primary key from each of the two tables into the third table. As a result, the third table records each occurrence or instance of the relationship. So in here, order details table is our junction table. Each record in the order details table represents one line item on an order. The order details table's primary key consists of two fields, the foreign keys from the order table and the product table. Using the order ID field alone doesn't work as the primary key for this table because one order can have many line items. The order ID is repeated for each line item on an order, so the field doesn't contain unique values. Using the product ID field alone doesn't work either, because one product can appear on many different orders. But together, the two fields always produce a unique value for each record. In this database, the orders table and the products table are not related to each other directly. Instead, they are related indirectly through the order details table. The many-to-many relationship between orders and the products is represented in the database by using two one-to-many relationships. The order table and the order details table have a one-to-many relationship. Each order can have more than one line item, but each line item is connected to only one order. The product table and the order details table have a one-to-many relationship. Each product can have many line items associated with it, but each line item refers to only one product. From the order details table, you can determine all of the products on a particular order. You can also determine all of the orders for a particular product. Another type of relationship is the one-to-one relationship. For instance, suppose you need to record some special supplementary product information that you will need rarely or that only applies to a few products. Because you don't need the information often and because storing information in the products table would result in empty space for every product to which it doesn't apply, you place it in a separate table. Like the product table, you use the product ID as the primary key. The relationship between this supplemental table and the product table is a one-to-one relationship. For each record in the product table, there exists a single matching record in the supplemental table. When you do identify such a relationship, both tables must share a common field. When you detect the need for a one-to-one relationship in your database, consider whether you can put the information from the two tables together in one table. If you don't want to do that for some reason, perhaps because it would result in a lot of empty space, the following list shows how you would represent the relationship in your design. If the two tables have the same subject, you can probably set up the relationship by using the same primary key in both tables. If the two tables have different subjects with different primary keys, choose one of the tables and insert its primary key in the other table as a foreign key. So, determining the relationships between the tables helps you ensure that you have the right tables and right columns. When a one-to-one or one-to-many relationship exists, the tables involved need to share a common column or columns. When a many-to-many relationship exists, a third table is needed to represent the relationship.